What factors influence oxygen delivery by hemoglobin? Imagine your blood as a busy delivery service, constantly transporting oxygen from your lungs to every part of your body. But what makes some deliveries faster or slower? That's where hemoglobin comes into play. Hemoglobin is a protein in red blood cells that carries oxygen, but its ability to do so depends on several factors. These factors influence how tightly hemoglobin binds to oxygen in the lungs and how easily it releases oxygen in the tissues. Understanding these can help explain how your body adapts during exercise, stress, or illness. First, the partial pressure of oxygen in your surroundings is key. In your lungs, where oxygen levels are high, hemoglobin binds oxygen very strongly, becoming almost fully saturated. When blood reaches tissues where oxygen is scarcer, hemoglobin releases its oxygen load to meet the body's needs. Next, the acidity level or pH of your blood also plays a role. When your tissues produce more carbon dioxide, they become more acidic, lowering pH. This causes the hemoglobin to release oxygen more readily, which is essential during physical activity. Conversely, higher pH levels make hemoglobin hold onto oxygen tighter, reducing releases. Carbon dioxide levels in your tissues are another important factor. Elevated carbon dioxide causes hemoglobin to change shape slightly, making it easier for oxygen to be released. This is part of what is called the Bohr effect. Temperature also influences oxygen delivery. When muscles work hard, they generate heat, which decreases hemoglobin's affinity for oxygen. This means oxygen is released more easily where it is needed most. Cooler temperatures, on the other hand, make hemoglobin hold onto oxygen more tightly, which can slow down delivery. The molecule called 23-bisphosphoglycerate is produced in red blood cells and can bind to hemoglobin. When levels of this molecule increase, such as in high altitudes or anemia, it reduces hemoglobin's affinity for oxygen. This encourages more oxygen to be released to tissues. The type of hemoglobin also matters. Fetal hemoglobin, which is present in unborn babies, has a higher affinity for oxygen than adult hemoglobin. This helps the fetus extract oxygen from the mother's blood efficiently. Abnormal hemoglobins or oxidized forms like methemoglobin can interfere with oxygen delivery by changing how well hemoglobin binds to oxygen. Finally, carbon monoxide is a dangerous gas that binds to hemoglobin much more strongly than oxygen. When carbon monoxide is present, it blocks oxygen from attaching to hemoglobin, severely impairing oxygen delivery. So, in summary, many factors influence how well hemoglobin can load and unload oxygen. These include oxygen levels, pH, carbon dioxide, temperature, and certain molecules within red blood cells. All these factors work together to ensure oxygen gets where it is needed most, supporting your body's energy and function.